copper and zinc and your
metals and non-metals. So many videos and things are there for us to see, and we want to study various properties of metals. Again, this is a very basic chapter. This will again come when you go in 9th standard. But that time, you would be learning to write the reactions, how the metals are obtained, their processes, electrolysis, reduction, oxidation, this kind of things. Again, this chapter will come if you go to 12th standard. So that time we will study some more details about various metals, non-metals and elements. So today let us start with the chapter metals and non-metals. Now, metals are basically some materials. Materials means we use them to make some objects which we want to. So generally various objects you might have seen. For example, this is made up of metal. Have you seen this anytime? A bijagar. It is made up of iron. Lokhand. This is made up of iron. Then show like this or like this. Okay. Yeah. Do not unnecessarily produce chaos. This is also one metal. The screws and the things, nails are made up of metal. This all things are metal objects. The pin, it is a metal, coin, metal, this L-shaped support, a metal, it's quite strong, not very easily you can break it. So various metal objects. Apart from that, this one is also I have got a big metal object. See? Metal object, correct? And metals have basic property. One thing is they are very strong. Very strong. Now this is very strong. Not if you put some water, it will not get broken. Even if you drop it, it's not going to get broken. And with your hands also you won't be able to crush it. Now you imagine you make this out of thermocol and then you put some food into it and then you try to lift it, maybe it will get broken from one side. Then there is one more advantage of metal is like it doesn't melt easily. Like if you take some wax and then you start heating it, it melts. But this metal doesn't melt. Even if you keep it in flame, it doesn't melt, and that's why you can use it to cook the food. So metals have got many different and useful properties. One important property is that was shine. Chaki, ekdam shine. Okay. So if you polish it a bit, it starts shining. One more very nice property is they produce sound. They are called sonorous. For example, here I have a spoon, and then very nice sound it will make, right? So ghanti is like that only. Ting, it is made up of metal. Now you use the same thing and then you use some other thing like this board. That makes good sound. Some dub sound it makes. Whereas this one is very pleasant sound it will make. Therefore, it is called sonorous. So metals have got various properties. And those who are not metals, they have some different properties. So in today's chapter, we want to study these basic properties. Now we'll ask property means what? So generally, when we say I have some material and when we are studying the properties, we are talking about two types of properties. One is physical property. Physical property means like how it looks, appearance, whether it is strong, whether it is solid or liquid, whether it is like it can allow electricity to go through, whether you are able to hammer it and it gets broken, whether you are able to pull it and it gets broken. These all things are called physical. Whether it gets dissolved, these are called physical. And then second is chemical properties. Chemical means how do they react? There is a thing called as chemical reactions. So we want to study like whether it will react with oxygen, whether it will react with acid, whether it will react with water, this kind of. So both we want to study. Okay? So that is like our main topic.
Hello.
So before we start, few objects we have already seen. But here few more of this I want to show. So all of you try to see them very carefully and try at the end we will write few things which we have seen. And we will not be very lazy. Few things we will write even. Not pages after pages like we will not have to learn English language as such. But this we will do thoda part so that it will help you to remember. So here Udita has many samples and she is trying to show them to you.
Hello everybody. Today we want to study the topic metals and non-metals. So over here I have got many interesting things and samples for you to see. So let us start studying them. The first metal we want to see is copper. Here I have a copper cube. This is a copper vessel. We can identify copper by its characteristic reddish brown color. Now since copper is malleable, we can even make thin sheets out of copper like this. And copper is also ductile, so we can have wires made of copper. Copper is a very good conductor of electricity, and so in electrical wires like this, copper metal is used inside like this, and this is a rubber insulation to cover it. This is a copper bottom vessel. Since copper is a good conductor of heat, it spreads the heat uniformly over all the sides, and so the food inside gets cooked uniformly.
Now what do we mean? Iska meaning is like this. This is the copper bottom we are talking about. Okay? At your home also you will find this. Now this is a copper plate which is stuck to this. If you remove that copper plate, there will be this type of metal, steel metal will be present. Okay. Now the use is, if you heat, you keep this on the gas flame, and then you will put some rice or something which you want to cook, and you will start the gas. Now what will happen? That gas flame will make contact at some point, somewhere it will touch, not everywhere uniformly. Now wherever the gas flame is touching, that area will become very hot. So exactly on the top, this point will be very hot. So whatever food or rice is over here will become very, very hot, and then afterwards it may burn. Compared to that, the thing which is somewhere over here on the side will not become that hot, and so it will remain uncooked. So what will happen is, when you are frying something, some part will start to getting burnt, whereas other part is kacha. What the point? So what we do, we put a copper plate. Now what will happen? You heat it at one point, but the copper is a very good spreader. It will spread the heat everywhere, and then the whole thing gets heated uniform. That is the reason why we have copper bottom vessel. Again, let us next one.
The next metal is zinc. This is a zinc cube, and this is a sheet made of zinc metal. You must have seen a dry cell like this. Inside that, this zinc sheet is used. Over here, this is the zinc sheet inside. This sheet is also taken from a dry battery cell. So this was copper metal, and this was zinc. And now, if you take these two metals and heat them till they melt and then mix them together, we get an alloy called as brass. And you can see that the appearance is completely different from the original metal. See the color of copper and zinc, and just see the color of brass. So this is brass, and this is a vessel made of brass. And here I have some brass nails. So brass is an alloy of copper and zinc. Now here I have 3 more cubes. You can see that they are looking more or less similar. They have the same silvery color. One of them is iron, one is aluminium, and one is lead. Now can you think, I want to find out which one is made of iron. What should I do? I think you must have been able to guess. We will use a magnet. Let us see. So this one is made of iron. Now we have 2 more cubes here. And if I hold it in my hand, I can feel that this aluminium one is very, very light. And this lead one is quite heavy. So now we will use a digital balance and check their weight. So here we have a digital balance. This is the aluminium cube. Its weight is 45.6 grams. And this is the lead cube. Its weight is 161.7 grams. Quite heavy compared to the aluminium cube.
Have you seen that? The difference? The aluminium one and the lead one. Now, this is same in shape, but this is 3 times heavier. And therefore, if you want to make an aircraft, what metal you will use? Will you use lead, heavier one, or aluminium?
Aluminium.
Aircraft out of lead, it will be so heavy that it is never going to fly. We have to use aluminium. But on the other hand, if you want to make a bullet which you want to fire at your enemy, and your enemy must die due to that, then you use lead, which is heavy. So hit your enemy, and lot of things will happen. If you use lighter material to make a bullet, like thermocol is very, very light. So you use a bullet of thermocol and fire it. Then no damage will happen. Your enemy will catch it, throw it on your face only. It is of no use. So for that purpose, we have to use heavier metal. So this is the lead block. Alright.
Then why do we use lead for bullets? Also fly, na?
Why we use it for bullet? Lead we use because it is very heavy and then it can damage your enemy. When it hits us, it is so heavy that it gives a big impact and it kills us. That's why.
But sir,
Now this lead metal has one more property. It is quite soft and it can be easily cut with a knife. Also, you can draw a line with it on a piece of paper. If you rub it on the paper, you will get a line.
That have you seen? So that means the lead is useful to draw a line and therefore we used to use a piece of lead metal in the pencil and therefore you can write. But later on we realized that lead is quite poisonous and small kids like you people, like you will use pencil for some time in the school and remaining time what will you do? Correct? आधे लोग के pencil पूरा चबा के, so that is not a good idea. You will end up eating some amount of lead. Therefore, nowadays we do not use lead in any pencil. We just call it lead, but we don't put lead. We use graphite, which is not that poisonous, and we use mixture of clay and graphite. So that is the reason why lead is called as lead, but it doesn't have lead.
These are all things made of aluminium, cylinder, cube. It's malleable, so you can make a thin foil like this. It is used in wrapping sandwiches and food stuff. Aluminium is also a good conductor of electricity, so it is used in electrical wires also.
Low quality wires. So few metals we have seen. So what we have seen, सबसे पहले I think few more also we'll see, but we'll make a short list of things. So what we have seen, first thing, basically metal. What are we seeing? Metals. So first metal, I will show you. You write the name. What was this? Udita had shown you just now. Right, Bharat? Copper.
Copper.
What other metal we have seen? One blackish color metal was there.
Zinc.
Adding those two,
कोटेशन करना है आपको दिखाते रहेंगे आप अपना सैम्पलिंग करते रहो
brass.
tell him to start whatever he knows wherever he stuck tell him to ask you.
Symbol. Copper is CO, but the symbol is Cu. Because there is one more name called cuprum. Cuprum, it is Latin name. The symbol in chemistry is this one. And then zinc is this one. So, this thing. Then Udita had shown you one metal which was sticking to magnet, which was definitely all of you right. Do not keep on talking, right? And you just raise your hand. Okay, let us see at the end how many of you are going right. There was one more thing with which you can build aircraft. That was aluminium. And there was more with which we can draw a line. You write the name over here. Can make a line on paper. That also is that show. And it is very heavy. So what do we do? Iska use making aeroplane, correct? No. Don't make aeroplane. Bullets. Right, bullets. Alright, so 6. अभी आगे का दिखाता हूँ. Now all of you note it again carefully. This much is okay? What is the answer to this? Obviously iron. And इसका lead. Many of you have sent correct answer in the chat also. Lead.
Please tell them to
Alright, आगे.
sisters तो obsessed
Here few more samples are there.
Some more metals. This is gold.
Means that liquid is not gold, okay? The small pieces which are there floating kind of, they are gold.
because since like the last 1 year or whatever they
This is silver.
every 3 months she's going to the hospital.
Narayan Das, Manohar Das, Shuddha Chandi. You can see black color at the edges. That is actually silver sulfide.
It's kind of rust, but not rust. It is silver sulfide.
Silver.
There is a powder called pitambari. Have you seen that anytime? Puja mein many people use these articles, okay? Silver, a spoon will be there and a dish is there, जिसमें भगवान को रख के सब पूजा वगैरह. So that people use once in a while, like Ganpati mein people will use. But then after that, if you keep it in the cupboard for a long time, it becomes black. And then to get the shine, you have to use that and rub it. Like so, the outer layer, which is black color sulfide, is there. That will go, and then it will start shining again. So that is the property of silver.
This is mercury. It is liquid at room temperature, used in thermometers. This is a metal called neodymium. It is used to make very strong magnets.
And what would be a brokerage?
Very strong. Now it's difficult to pull this out.
Half a month. Anyway, this is only for 1 year.
This is an element called bismuth.
I can understand. Can you repeat that?
This chakli is magnesium wire or magnesium ribbon.
This can bend very easily. See, iron cannot bend that easily.
This is an iron nail. When it is exposed to air and moisture, it gets rusted like this. This rod is made of stainless steel and so it does not get rusted even if it is exposed to air and moisture.
Got out.
Here I have some iron filings.
So if you're paying 1 month brokerage, then we'll come up to the same thing. No? It doesn't make sense for us. I'll be able to do half. Sorry.
This piece is made of cast iron. That means iron plus a comparatively large amount of carbon as compared to steel. It is also called pig iron. It is very hard. That means it is very difficult to make scratches on the surface. Also, it is brittle. That means if you drop it from a height or if you hammer it, it will break into pieces. This one is a piece of galvanized iron. That is iron coated with a layer of zinc.
These two objects you might have seen. This one so is useful, like दूसरा part दिखाता हूँ इसका ये.
This piece is iron, steel. It is also called pig
Have you
iron.
seen this type of thing anytime? ये guitar की जो coverings होते हैं ना, they are like this. They are made up of cast iron. They are quite strong and sustainable. Therefore we use it. And this yellow color pipe also you might have seen. Where is that? This one. This one. Have you seen this yellow pipe anytime? Mahanagar gas pipe. Some buildings have got pipeline gas supply. So on the sides of the building we find yellow color pipe goes like that. That is exactly this pipe. It is called galvanized iron pipe.
Some galvanized iron. That is iron coated with a layer of zinc to prevent it from rusting. This is a soldering wire. It is an alloy of tin and lead. It is very soft. It has a low melting point and it is used for soldering electronic components and wires. This one is a nichrome wire. It is an alloy of nickel and chromium. It has a high melting point and it is used in ovens and toasters. This piece of rock is a chemical called iron pyrite. That is actually APS, iron and sulfur. It shines like gold, and so for many years people thought that they could extract gold from it, and many attempts were made to get gold. But actually it doesn't contain any gold, so no one was actually successful, and that is why it got the name Fool's Gold.
Fool's gold. Fool's gold is not metal. It's just like for many years people used to try getting gold out of it because gold is so expensive, and therefore it is called fool's gold. Fool means मूर्ख लोगों का gold. Means there is no gold. They were just trying to get it somehow, and of course they are not going to get. Anyway, so some of the samples we have seen. Now let us start our study. Correct. So we want to study various properties. Physical, it will include looks, heaviness, capacity to flow the heat or electricity, whether they melt, whether they don't. And chemical properties means ability to react chemical. Correct. Now basically, even if so many different metals we have and we use, like from what they are made up of. Correct. So to answer that, basically there are only three substances in the world, three particles. One is called proton, second is called neutron, and third is called electron. And they are very small, extremely small. And the entire world is made up of only three things. Everything is made up of only three things. Like for example, iron is made up of proton, neutron, electron. Copper is made up from proton, neutron, electron. Gold is made up from proton, neutron, electron. Even water is made up from proton, neutron, electron. You people are made up from proton, neutron, electron. Cow dung is made up from gobar, proton, neutron, electron. So basically it is same stuff only. You people, gobar, same thing. Proton, neutron, electron. But still, it is not that proton, neutron, electrons are randomly mixed. What do? They always come together in form of a planetary model kind of a structure. Planetary model means what? Sun at the center and planets rotating around that. In a similar way, these all things are made up of proton, neutron, electron, but they have a structure, and that structure is called an atom. Structure is called atom. Now, there will be a small center for the atom, very small. In that all the protons and neutrons will sit. All. And then there will be some shells. Around that the electrons will keep on moving. So it's like sun at the center and tiny planets called electron going around. Therefore we say it is like a planetary model. Okay. Now in this, each atom will have some protons, it will have some neutrons, it will have some electrons. Now in all the atoms, these protons and electrons are always same. This and these are always same. Always same. This can be different. Now the properties of that particular small thing depends upon only one factor, and which is how many electrons and protons it is having. For example, if this has got only one proton and zero neutron and only one electron, then the atom is called hydrogen. One atom you cannot see, of course. But if you have billions of them, that becomes a gas, and it has a property that if you put it into a balloon, the balloon automatically starts going up. It is very light gas called hydrogen gas. Have you heard of that such balloons you have seen? बस heart shape वाले balloon आते हैं. They can be made with the help of hydrogen. On the other hand, if you put two protons are there, two neutrons are there, and two electrons are there, this gas is called helium. It doesn't react with anybody. Hydrogen can like blast and it can very quickly burn, but this doesn't. So this is also lighter than air. Therefore, in the balloons, you can make the balloon go up even by this or by the earlier one, hydrogen, but we prefer this. So on, like now if there are 20, this one neutrons for time being we will not pay attention. Now if there are 26 protons and 26 electrons, this is called as iron. This is called as iron. If there are 78 and 78, it is called gold. If there are 80 and 80, it is called mercury. Like that, different things are. And therefore, the properties of the substance depend upon this number. This number is quite special. And like you people have roll number in your school, here also it is called roll number, but instead of roll number, it is called atomic number. Make sense? And then in the school, how you people are arranged according to the roll number. In the same way, we go on getting different elements with material with roll number 1, material with roll number 2, material with roll number 3, material with 4, 5, 6, like that, and we arrange them in a beautiful table, and that table is called as periodic table of elements. So let us quickly see this periodic table of elements. And you will find that in this periodic table of elements, it contains list of almost all the things which we have seen. For example, hydrogen is roll number 1. See in this corner. See that? And then let us try to trace many metals we have seen. Udita first he has shown you copper. Copper is roll number 29. Cu. Are you able to locate that? Over here.
मेरे को प्रेशर मत डालो यार.
है कि नहीं? Copper के बाजू में there is zinc. That also we have seen.
हमको लगा तो आ जाओगे ना
Then we have seen iron, which is the same row but over here, 26. Then one chakli was shown to you. You remember that? I said, and it was possible to bend. What was that?
मार्जरीन का क्या है वो मेरे को बोली थी थर्सडे फ्राइडे
Magnesium. Let us see if we can find it. Here, that means you people pay attention. Good. This is number 12. See, Mg is magnesium. And then we have seen aluminium, and that heavier one was lead. It lies over here. 82 lead. 82. And then there was one bismuth, which is 83. उसके बाजू में roll number 83. And in the same line there was gold, mercury, roll number 80, and gold 79. What I said? 78 I said? No, 79. 78 is one more good thing called platinum. It is also shiny and good element. There is gold, and उसके ऊपर there is a silver, that small nag and small chip with that shown 47. So you will find so many these things, elements are there. Roll number 1, roll number 2, roll number 3 lithium, 4 barium, 5 boron, 6 carbon, 7 nitrogen, oxygen, 4 chlorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, light, so blah blah blah. Now one thing you will ask, like, why this table is so ada-teda, like some people here and then gap and some there, why not to make? That has got a very difficult reason to explain. And currently you assume that we have arranged them in such a way that all those who are in one line, they are similar in behavior. Similar. Means if one is reactive, this one is reactive, then this will be reactive, then this will be reactive, and so on. Means we have arranged them so that all the similar people are in one line. These people are similar. Similarly, this fluorine, bromine are similar. Similarly, helium, neon, argon, krypton, they are all similar. And that is why, by taking this arrangement, similarity we want to be in one corner. Therefore, we have to make this टेढ़ा-मेढ़ा a bit. टेढ़ा-मेढ़ा means थोड़े से एक corner में, थोड़े से दूसरे corner में like that. Second question we will ask is, okay, by taking one proton, one electron, we get hydrogen. 2 proton, 2 we get some other thing. 26 and 26 we get iron. 30 and 30 we get zinc. 79 we get gold. 80 we get mercury. So this will never stop. Like you can have something like 1000 protons in the center and 1000 electrons rotating around them. So actually that is not the case. These protons have got one more property called charge. We will study a bit about this when we study electricity. And they have a property that any two protons when come together, they always repel out. They repel. Magnet, have you seen magnet? Magnet can attract, but if you flip it, they repel. In the same way, two protons always repel. And therefore, if there are protons number more than 83, 83 कौन है देखो periodic table में, see who is 83.
नेक्स्ट टाइम में सी रही है.
Tell if you can find it out.
नेक्स्ट टाइम
ये इधर है देखो, bismuth. Have you ever seen that bismuth? Never seen that, ना? Not seen at all anytime. Anybody has seen that anytime? Very good. क्या तुम लोग करते हो? देखो अब ये.
इसका जॉब एप्लीकेंट फिल था.
नो
हाँ?
नो वर्चुअल वाले अभी भी नाम शेयर नहीं कर रहे थे, नाज़रीन नाम.
क्यों?
मैं बोला उनको.
This is an element called bismuth.
What? Bismuth. The small metal pieces are made up of bismuth.
एक इंटरव्यू.
हाँ. उसको
दिखाना है?
बात करने कैसे करते हैं?
Now tell how many of you have seen that previously? Many of you, very good. Now why we purchased that is one thing we wanted to show it to you. But that bismuth has got a very specific thing. If there are 83 protons in that tiny nucleus, they repel but still they are able to remain happily. The moment you add one more and make it 84 or 85 or 86, anything more than that, then it doesn't remain stable. It sometime or the other it splits into something. It is called radioactive elements. They are unstable. Bismuth is the last person which is stable. समझ में आया कि नहीं point? So that's why it is like slightly different. One more property is there for this bismuth. Usually, if you heat a substance, it becomes big. You take a metal rod and heat, it becomes big. But bismuth, if you heat, it becomes smaller. That is one weird property it has got. And one more weird property. If you have magnet has two ends. It is called north and south. Now, if you take some iron piece If you bring north, it attracts. If you bring south, then also it attracts. So iron attracts to both the ends of the magnet. But there are some substances who don't attract. So there are some substances who attract to both the poles, and some are who don't attract. We call them non-magnetic. Now bismuth is one more different type of a thing. Bismuth shows repulsion to both the poles. You bring north, it repels. You bring south, still it repels. One more, it's a weird substance in a way, bismuth. And after that, all the elements, since the protons repel each other with such a great force, the element atom doesn't remain stable. It blasts into something else, chota mota pieces. And therefore, the periodic table number of elements finish after a particular level. You cannot have something like 1,000 protons together, and we don't get anything something like that. At the most, like here, if you see na, after 83, all those, this polonium, this 85, 86, these all are radioactive. In niche wale line mein, they are also, here there is uranium, number 92. And then there is neptunium, plutonium, like that, various things are there. And after that, our names got over. These elements are so unstable that sometimes it is possible to make them in the laboratory by bombarding some neutrons together. But they don't remain stable. Within fraction of second, they split into something else. So you just will theoretically say, okay, I have got some metal and it was existing for 0.01 second. And the names are also very weird. At the end, सबसे पहले Uranus, Neptune, Pluto तो हो गया. उसके बाद people started giving names from the names of scientists. Einsteinium, Neptunium, then Niels Boronium, something like that. And then the people started giving names from mountain, like Mount Everest के ऊपर एक name and something like that. At the end, so there are names like UUP, UUN, Ununium, kind of the elements. So they literally have got no use to us. Means you will never find an object like a metal pin made up of ununium or something, because it is not going to remain stable even for 1 second. What is the point of having that? On the top of that, when it explodes or when it splits, it emits some harmful particles which hits our cells and kills the genetic material inside, and that has got cancer giving capacity. So we don't have something like that. They are just for the sake of study. Now this periodic table have got various elements, and therefore after 83 it is stable and then it's going to stop. And therefore this periodic table has limited number of things. Limited number of things. Now so many elements are there. We divide them into 3 parts: metals, non-metals, and metalloids. And they are like this. All those who are in this pink color, they are all metals. ये देखो, aluminium, lead, bismuth, mercury, iron, all are painted in pink color. All those who are blue, they are called non-metals. They are not like metal. And there are few people who lie in between. They show some properties of metals, some property of non-metals, and therefore those people are called metalloids. Metalloids. So the elements have 3 parts: metals, non-metals, and metalloids. That makes sense? Few metal samples we have seen. Now some non-metal samples we will see. The trouble with non-metals is that non-metals are there, but many of them are in gaseous state, like oxygen is a gas, neon is a gas, argon is a gas. So not possible to see them as such the way we were able to see for metals. But still, here some non-metals are there.
In the periodic table, most of the elements are metals. Very few are non-metals. And out of them, most of them are in gaseous form. For example, oxygen, nitrogen, helium, hydrogen, argon, neon. So they are there everywhere around us. But I cannot really show you that this is hydrogen. Look here, this is oxygen. So that is not possible. There is only one non-metal which is in liquid form, that is bromine. And few of them are there in solid form. So
only one non-metal is there, which is called bromine. Uska one video is there, we'll see it later. Okay? Few are in solid form, that we want to see.
Now let us try to see some of the non-metals which are in solid form. The first non-metal we want to see is carbon. It can exist in different forms. They are called allotropes of carbon. For example, this is coal or kolsa. It is used as a fuel. Good source of energy for us. If it is rubbed on a piece of paper, we can get a line like this. If I rub it on my finger will also turn black, see? Another form of carbon is graphite, which is used in your pencils. The tip of the pencil is made of graphite. Now this graphite is a good conductor of electricity. So it is used in dry cells. This rod is a graphite rod. Generally, metals are good conductors and non-metals are bad conductors of electricity, but this graphite is an exception. Diamond is also a pure form of carbon. It has a very beautiful shining appearance. So it is used in jewelry. It is quite expensive. This is a glass cutter. It has a very tiny diamond at its tip. Let us see it in close up. You will see something shining at the tip that is made of diamond. Now glass is very hard. So we cannot cut it with a knife. We need something that is harder than glass. And so we use a diamond.
Able to see this diamond? Now this cutter is called glass cutter. The people who sell mirrors and glass, they use this and therefore they can cut the mirror to the size. Now cutting means you have to make a scratch and then you have to keep it on the table and just slightly you have to give impact so it gets broken exactly on the same time. More about this when we study a chapter called natural and man-made material. So this one is called glass cutter. Which was this element which we are seeing? Which was the element? Coal, graphite, Sark, which one?
Diamond, sir.
No, which element? Carbon. Element was carbon. It is a non-metal. Have you seen that in the periodic table? Try to find it out and tell me the roll number. Let us see who is able to do that, okay? Showing the periodic table quickly. Tell. Find the non-metal, carbon, and tell the roll number. Able to find? Many of you. See here, blue color mein. This is one. Now this carbon has got 4 different forms. Coal is also carbon and diamond is also carbon, but they look very different and therefore price is also very different. Okay, coal is used to burn and diamond is not used to burn. People put it into like gale mein dalo, naak mein dalo, khan mein dalo. Now it is carbon. Now nobody will put a coal like this gale mein ya fir naak mein, kaan mein, coal ka tukda. It is same only. Chemistry wise it is also carbon. The diamond is also carbon, but looks make a lot of difference. This property is called allotropy. What does it mean? Same thing, but it looks so very different. And therefore, this property, why this looks different is arrangement is different. The inside that coal has got just carbon randomly thrown here and there. But when they get arranged in a proper crystal, it looks shining and then we get diamond. So that was a non-metal carbon.
This yellow color powder is sulfur. It is
also element. All of you quickly identified. Periodic table mein. Roll number bolo kya hai? Sulfur. You have to search in that blue color corner only because it is non-element, non-metal. SS16. See? Very correct. Most of you are able to find. So that is the sulfur powder. It is in form of powder.
non-metal.
This powder is slightly poisonous.
Sulfur can also exist in yellow crystalline form. This is the amorphous form. Phosphorus is also a non-metal. The sides of the matchbox are coated with red phosphorus on which we have to rub the matchstick. Iodine is also a non-metal. These are iodine crystals. Iodine is sublimable. That means when the solid crystals are heated, they will directly get converted into gas. These purple fumes which we see are iodine vapors or iodine gas. Now here, cold water is kept in a round bottom flask on top of the beaker. So the iodine vapors start solidifying as they cool down. And these are solid iodine crystals which get accumulated on the bottom side of the flask. They can be scraped off and we will get back our solid iodine.
So we have seen carbon, sulfur, phosphorus on the sides of the matchstick, and then iodine I. These are the four non-metals which are in solid form. Therefore, we can see. And then the fifth one is liquid form, which is this bromine, which we'll see after some time. So few samples we have seen. Now various properties we want to see. So generally, like what properties they have? Metals are solid at room temperature, whereas non-metals, some of them are solid, some of them are liquid, most of them are gas. Metals are shining if you polish, non-metals are not shiny, they don't have shiny appearance. Metals conduct electricity, non-metals usually don't conduct electricity, except like graphite, which can. Metals conduct heat, non-metals cannot conduct heat. Metals can bend without breaking, means you can hammer them and you can make sheets out of them, but non-metals cannot be. And you can stretch metals into wires, again, non-metals may, that is not possible. And that's why this copper sheet is there. Now you can take a metal cube, hammer it and make a sheet. But you cannot take material like chalk, hammer it and get a thin sheet of chalk. That's not going to work. You will get powder of that, but not a thin sheet. This property is called malleability. Now you'll ask, how we get these metals? ये metals मिलते कहाँ से? So we get this by mining. Mining means soil is there ना, तो तुमको खुदाई करनी है. And from that you get stones or some materials which contain the compounds of this. This is like ancient process which we used to get copper. This is called mining copper.
This is malachite and it contains the element copper. And this is pure copper metal. For thousands of years people have known how to extract this metal from the rock.
What's your tool?
The first miners used large stones to dig out pieces of the precious green rock. Malachite. First, the malachite is crushed, then it's placed in a crucible ready for heating.
You have to powder that stone. Then,
in the Bronze Age, copper ore was smelted in a small furnace made of clay. Temperature. Then, in goes the crucible and it's covered with charcoal.
charcoal and heat.
The charcoal reacts with all the other elements in the malachite, leaving behind the copper.
Then you get liquid
The
metal.
result, liquid copper, an element. Once the copper has been extracted, it can be poured into a stone mould. It quickly solidifies and begins to take on the shape of an axe head.
See, this is the axe blade which is made out of copper. In the same way, tin also can be used.
This tin, it contains oxygen.
This is a stone which is tin element.
Smelt it, and once again, the pure metal is left behind. Copper and tin are both elements. So what's the difference between one element and another?
These are copper and tin, dono ke axe. This is how people used to make the weapons in very old time. And therefore there was Iron Age, Bronze Age. So the idea is if you can make such a kind of thing, then you will get a lot of power, like you will be able to defend yourself or kill other animals, because other animals don't know how to make metal weapons. And that's why humans became more and more stronger and powerful in the prehistoric times. Now you will ask, can I extract metal at my home? So this is one small experiment that Purita has done, okay, just for interest, not there for us to study. There is a thing called as copper sulfate. And we make one kit, in that also it is there. So that copper sulfate can be used to extract copper. Okay, the idea is copper sulfate has formula Cu and SO4. In that, if you put iron, then that iron reacts with this SO4 and throws out this copper. So this copper comes out. And this copper comes out in form of powder, which can be collected. This is how it can be done. This is a copper sulfate which is there in the science kit or in school laboratory also. If you get chance anytime when the school starts, that time you try doing it. First you have to make a solution of this. Here there is a bluish color copper sulfate. So this copper sulfate solution has got very nice blue color. One iron nail is there, it is washed and then copper sulfate is put into copper sulfate. Now that iron reacts and it becomes ferrous sulfate. Ferrous sulfate is greenish in color, not bluish blue in color. And therefore, slowly after the reaction, copper will be thrown out and the solution starts looking green in color. And then if you see the nail, there is small copper powder deposited on that. Once the reaction is over, now it's time to extract that copper. So here Rita has removed out all the water. This is in fast forward, of course. And then to get pure copper, maybe you wash it 2-3 times and now see the difference. Huh? This one was copper sulfate, blue. And this is ferrous sulfate, which is slightly greenish in color. And this is what has happened to that nail. So you put some water and separate that copper pieces. The remaining iron nail, and this is the copper powder. Can you see the color of that powder matches with that vessel which we have seen earlier and the cube which Ulta had shown you? Because it is same element, copper. So if you want, then you remove all the water and wash it properly. That can be done in the same process. Remove all the water quickly, so whatever impurities, some amount of ferrous sulfate will be there, that whole thing will be left, and then you will get this kind of copper. You want to wash it 2 times to get quite a pure thing, and then whatever is remaining, you spread it a bit and then allow it to dry. See? And after keeping it for 1 day or so, this is the beautiful copper powder which you can get. In that, so this is a pure copper metal extracted from that blue solution. Correct? Have you seen that? Now you'll ask, is that powder same as this cube? Answer is yes. Is it possible to get the cube from that powder? Answer is still yes. For that, again, same thing. You need to heat it to a very high temperature. And then it melts, and then you pour it into a stone cavity, and then you will get the cube or a goli or whatever shape you want. So, chemistry-wise, it is same thing only. Now, this periodic table, so many elements are there. Out of them, we want to study the property called reactivity. Now, some of them are very reactive. Quickly and vigorously they react. All those who are in this first column are very, very reactive. Who? Li, lithium, sodium, potassium, rubidium, cesium. They are very reactive, extremely reactive. They are very soft and quickly they react with oxygen to form oxide. They have shining appearance.
There are 6 alkali metals: lithium, sodium, potassium, rubidium, cesium.
If you cut it, it has got shining metal surface, but if you put it outside, very quickly it rusts within few seconds. Now, iron object if you have, you need to give 4 days, 5 days for it to rust. But this is rusting so fast, see? And now if you make the scratches again the shining surface will be there. This is the next metal, sodium. It is there in salt, sodium chloride. It is also soft. You can very easily cut it like this with knife. It is a metal, but you can add here. So quickly it will lose the shine and get a cover, a rusty cover. This metal is called potassium. Here the shine is impossible to see because within seconds it reacts with oxygen. Now if you put these metals in water, this is how they react so vigorously.
Now for potassium.
They literally
This time
flame on the top.
The heat given out by the reaction is produced so quickly that the hydrogen gas catches fire. It burns with a lilac flame.
This metal is called rubidium.
This time we put a safety
in water and reaction. The last one
You
is
can see that things gradually become more terrifying as we go down the group. Let's try cesium, our 5th alkali metal.
very small piece and they come very. These are all first column: lithium, sodium, potassium, rubidium, cesium. They are all very, very reactive metals. Out of them, only 2, these last 2, rubidium and cesium, are put into a bathtub. All of you see this. Small piece, 2 grams of rubidium in this bathtub.
Of the period.
Here it is.
Is that it? Well, it might not look like much, Richard, but it's a highly reactive metal. It's sealed in this glass tube under argon atmosphere conditions. Just for a second, imagine, if you will, letting...
They're trying to put it into a bathtub.
Okay, Tickle. Drop the rubidium in the water.
Stand back, everybody, this one's going to be bad!
2 grams of rubidium will only react when our specially designed vial dissolves in the water, which gives John a few crucial seconds to get into our safety zone.
Explosive. Like a bomb, but it is not a bomb, okay? It is a chemical reaction happening between the rubidium and water. See what has happened to the tub? That was metal rubidium, and the last one is very reactive. This is cesium.
Warning, extreme danger, clear the area.
Only 2 grams.
As our cesium sinks in the water, the rapid generation of hydrogen gas should produce quite an explosion. And it does.
Have you seen what has happened to this tub? That was this two, rubidium and cesium. This is the reactivity. They are very reactive. So chalo, let us see. Which one? एक book में एक line लिखो. Very reactive metals. And show if you are able to write. Let us see who is able to write. Very reactive metal. Omkar is able to write. Okay. Very reactive. Very reactive metals. You have to write the name of the metal, not only very reactive metal. आगे का तो लिखो. Which we have seen just now in these 2 videos. Lithium, sodium, potassium. These 3 at least you write. Lithium, sodium, potassium. Those who like chemistry, they like the remaining 2 also. Tanisha is able to write 2 things. The last one are called Gaurang is also able to write. But I am not able to see. And then that explosive ones were rubidium and cesium. These were very reactive. And they are all where? In the first column of the periodic table. First column. Have you noticed the place? First column. See this lithium first column में सब पहले column. These are super reactive. The people who are there in the second column, they are also quite reactive. उसमें से we will study about this calcium. Some compounds of calcium are there even in our bones. Our bones contain calcium, but not in metal form. Now, calcium metal. Here, this is a very nice video. Here, many things we can see. One is that the calcium is hammered to show you that it doesn't get crushed into powder. It is called malleable. Second, it is shown that it will pass electricity and the bulb glows. Means metals are good conductor of electricity. Then the third is it is put in water to show you how vigorously it reacts. Now all these metals react with water and they throw out hydrogen gas. So hydrogen gas is very light. You can put it into balloon and it goes up. So it's very easy to collect it. How to collect? You just take a vessel or test tube and invert it. All hydrogen gas will go inside and remain in. But if you want to check whether that is hydrogen or not, what you can do is you can take it and put it near flame. Now hydrogen has a property, it burns with pop sound. Pop sound comes. And then at the end there is one more property. There is a chemical called phenolphthalein he is trying to put. That phenolphthalein becomes pink in color. But this we will study when we study chapter.
Calm in group 2 from magnesium to calcium. We see that the calcium is also stored in the air. Instead of being a shiny metal, the calcium is coated with a layer of the metal oxide. As you go down the column in group 2, the metals tend to get harder. Calcium is malleable, but requires a great deal more force to shape it.
Doesn't become powder like chalk. Good conductor of electricity.
And does conduct electricity. If we add the calcium metal to water, we get a much more rapid reaction of the calcium with the water than magnesium. The reaction is very exothermic. This is due to the lower ionization energy of the calcium. We get a single displacement reaction producing hydrogen gas and the formation of slightly soluble calcium hydroxide. We can test for the hydrogen gas by collecting some of the hydrogen gas in a test tube and testing its flammability.
It makes pop sound. Isn't that
We
like
can test for the presence of calcium hydroxide by adding phenolphthalein indicator. The indicator turns purple, indicating that the solution is basic and that calcium hydroxide has been formed.
That is called phenolphthalein. So this was with metal, calcium, this one. So we have seen this and this. Now there is one video called gold. Gold is the best. Now these are very reactive. But the gold on the other hand is not reactive at all. Doesn't react with anybody. Therefore it is called inert. Okay? When this gold is the best video, what it is shown is that comparison of gold and other things. So you will try to put concentrated acids, sulfuric acid, nitric acid, hydrochloric acid, and show you what happens to other metals, and compared to that nothing happens to gold. That is the video. Gold is the best. See this.
Small piece of aluminum for
There is
comparison.
gold and aluminium, and there is concentrated hydrochloric acid. See what happens to aluminium? It reacts with the acid and completely becomes black, but nothing happens to gold because gold is the best. Now this is gold coin and copper nail and nitric acid is put down. See what happens to that copper. Nothing happens to gold. It remains shining because gold is the best. Now the gold coin and a sugar cube and concentrated sulfuric acid is put. What happens to that sugar? It becomes black, but gold is the best. It remains like. Now these are all three acids. Now he is trying to do the same thing with a very concentrated alkali called sodium hydroxide. It's very powerful. If it touches your hands, the skin kind of gets peeled up. Now he is heating gold coin with that, with a gas flame. You will find even glass bottle reacts with that and a hole is formed over here through which it is coming down. But the gold coin, if you see, it's still shining and intact. What might be the reason? Gold is the best. But in the exam you don't write gold is the best. Exam you write gold is inert. Okay? Inert means it doesn't react with anybody. That's why this was there. That compare. Therefore the name of the video is gold is the best. But there is one substance called aqua regia, which is mixture of two acids, which is freshly prepared. And in that aqua regia, if you put gold, then it is not best. It kind of gets dissolved. To show you that this is what happens in the aqua regia. First, the gold coin is taken and concentrated hydrochloric acid is added.
Now we add 10 milliliters.
And obviously nothing is happening because all of you know gold is the best. Now you add concentrated nitric acid to it. Now this is called freshly prepared aqua regia. In this mixture, it produces a thing called as chlorine gas, which is kind of able to react with this gold, and with that we get this gold solution. So the gold is getting dissolved into it. Gold is getting dissolved into it. Gold is the best, but not in aqua regia. And this is one of the ways to extract gold. Sometimes small gold-plated things are there. So they can be soaked into aqua regia, and then you will get yellow color solution, and then you evaporate that solution and get powdered gold. The way Udita has got that powder copper, do you remember that video? Copper ki powder. In the same way, it is possible to get powdered gold. Now these are liquid metals. Okay. This video you had seen probably how to make tea when we were having that parents meeting. How to make tea is like this. So here this person is having a spoon, and what he will do is he will put some boiling water and a tea bag and he will try to mix it with the spoon. See what happens. You mix it, you will find that surprisingly this spoon vanishes out. Why it is vanishing? Who is eating the spoon? So the answer is that this water is very hot. And this gallium is almost liquid at room temperature. So thoda sa bhi garam pani mein dalo, so it melts and becomes liquid. So that gallium is there at the bottom. You cannot drink it, of course, okay? That is just to show you that it is liquid. Here are a few more low melting point alloys which melt very quickly.
This is gallium, a metal most famous for its low melting point.
The one
This will melt in your hand, although on a cold winter day it takes a little patience. But you can see that some of it is melted.
So it is solid, but the moment you put it in
Gallium
your
does
hand,
not-
it melts due to heat of your hand.
Toxic, but when molten, it wets almost everything. Glass, your hand, and so on. But you can buy this special vacuum ampule with high purity gallium. The glass is treated with what I believe is gallium oxide, so the gallium does not stick to this glass, and you have a beautiful mercury substitute. So it's a fusible alloy of indium, bismuth, and tin. It melts
It is not
100.
metal. It is not there for us to study the name and anything. I just wanted to show you that it melts very quickly. This is one alloy, and therefore this video. So it is put in hot and boiling water, and we will find that it immediately melts. See, this is the solid metal. It melts and becomes liquid. Again, if you allow it to cool down, again it will become solid. ये देखो पूरा मेल्ट हो गया. Have you seen that? It is an alloy, means mixture of two or more elements. See, it is there at the bottom. This is that alloy. On the top of that there is warm water, of course. And then mercury. Have you seen mercury anytime? Yes, when today only that bottle was there, no? Have you seen yellow color powder? It is sulfur, it is non-metal. Have you ever seen that? No. Nobody has seen. Many of you have seen. Good. ये वाली powder bottle. Anyway. Now there is one more, next important. What we do is we mix two or more metals. And if we mix them, we get a thing called as alloy. So alloy is a mixture of two metals. For example, one alloy we have already seen, brass is copper plus zinc. In the same way, even mercury can make alloys. They are called amalgam. Bubblegum nahi, amalgam. Mercury plus gold is a quite useful alloy. It is called amalgam. Useful in the sense for dental mixtures it was used. Here, few drops of mercury are put on this gold foil. And you will find that they have a lot of affinity for each other, and gold and mercury gets mixed very, very easily, and they form this silverish color alloy, like this. As you add more and more gold into it, it will start becoming more and more solid. This is in fast forward, but it literally goes on getting absorbed in the mercury. The small gold films. Looks very beautiful. And then finally you will get the amalgam, which is mixture of gold and mercury. From this amalgam still it is soft because there is some excess amount of mercury. What we can do is we can crush and get rid of the excessive mercury like this. See? Although mercury is a poisonous thing and therefore it has to be handled with only those who know how to handle it. Here he has put it into a towel and crushed it so all mercury drops come out. And then there is a really hard kind of a substance inside. So this is a gold mercury amalgam and it was used as a dental filler in old times. If it is put in nitric acid, the mercury reacts, but the gold doesn't because gold is the best. And in that way, again, if we have amalgam, it is possible to put it into this acid and again get gold powder at the bottom. See? So this is the gold powder again from that same alloy. This is one more mercury plus gold amalgam. Mercury plus aluminum amalgam, sorry. This video is by a person called Nile Red. It looks very, very weird. And mercury goes on reacting with aluminum and forms a compound, a alloy, and that is quite brittle and kind of spongy in shape, so it comes up like, looks very, very nice. But it completely spoils fibrous substance inside and spoils this aluminum. And therefore, on the aircrafts are made up of mercury. On the airports, it will be written any form of mercury is strictly banned, because even a drop of mercury falls on the wing or the body of the aircraft, it goes on eating inside and forming alloy. So the aircraft will not have any strength at all and it will crash. Therefore, it is not possible. This is one more such example of amalgam. A metal channel is there, aluminium, and on that a drop of mercury is put. And you will find that it goes on getting inside, forming an amalgam. So the channel earlier was very, very strong. Now it will no longer become strong. All strength will be lost. It has got converted to amalgam. You've seen that? Slowly it is getting formed. So only one drop at the top is sufficient to corrode so much of aluminium. This is to show metals conduct electricity. Now copper wires, aluminium wires, we have seen. But even mercury conducts the electricity, in spite of being liquid. To show you that, this is one very good example. This bulb is put with the battery and connection. This is one more example.
There are many different designs, but the most common one is probably the tilt switch. If it's tilted in the right direction, the mercury will complete the circuit, turning on a light bulb or whatever the system is set up for. Mercury doesn't normally exist as a metal in nature, and it's usually found in the form of mercury sulfide, which is commonly known as cinnabar.
So this one was for extracting mercury. Have you understood the tilt switch? When the mercury drop went on one side, it completed electricity and the bulb glowed. So one use of that. Now the next property is metals are malleable, means we can make sheets out of them. How do we do that? You have to take metal and apply very high force. With your hands you may not be able to do, but here with a machine called press, a 10 cube is...
About 2 tons. But let's go 110 so we can get that same result. Okay, that's the first performance by far. That's super nice. It's giant tin coin.
That was a very, very big tin coin. You just hammer it, and then what this property is called? Malleability. What it is called? Malleability. Now sometimes what we do, we give a coating of one metal on the other. What we do, we give coating of one metal on the other. One example is this called tinning. This tinning was very common in the old time. Nowadays people don't use it. The reason is, in old time this stainless steel was not there. So you would have to use vessels made up of this copper or brass plates, cooking vessels. Now brass and copper is good, but the trouble is if you put some limbu or buttermilk or any acidic substance, it reacts and forms poisonous substance. And therefore you cannot drink that, then you will have vomiting, poisonous effect. So what we do is you take a vessel and coat it with a thin layer of tin. So that process is called tinning. Kalai, Marathi tera kalai asa banta. This is a process called tinning. Copper and brass vessels are coated with. The idea you have to heat the vessel and apply some tin. This is called tin plate. And then put one powder called ammonium chloride which sublimates. Fume will come, and then you will find that a tin coat has got formed at the bottom. You seen that? Tin ka coating. So like that you have to do coating all the vessels which are made up of copper and brass. But after that steel was developed. The steel doesn't rust, it doesn't react, and so nowadays it is stopped. When I was in school, at that time one person used to come to our house with kalai karke, and then everybody who has got copper and brass vessels have to give it to him. He will coat it with tin and give it back to him. That was the common process at that time. One more example of coating is called zinc coat on iron. It is called galvanizing. Why we do this is because otherwise iron objects catch rust. And if we coat, then they don't rust. Now this is a very good example of the use of this. How to do it is like its process is called electrolysis. You have to take one zinc plate and one iron nail. Now this is an iron nail and we want to coat it with zinc. So you put it into liquid, which is usually sulfuric acid, zinc sulfide, and pass electricity. When electricity flows, some zinc will go from here to the solution and then it will go here and get deposited on the nail. And then the whole nail will get coated with zinc. Such a thing is called galvanized. This nail has got now coating of zinc. This is the normal nail at the top, and this is the bottom where there is galvanized zinc. So to show you that, he is trying to purposely put this two, galvanized one and the normal one, in a moist condition. This is a paper which is moist, water is added, and you keep it for 3-4 days. And after 3-4 days, you will find the iron nail is completely rusted. The left side one, see, this is completely rusted. Rust has been formed. But here there is no rusting because it was coating with zinc. And under microscope it looks like this. The bottom one is galvanized one, zinc coating. The top one is the normal iron one which has got rusted.
In truth, actually, both nails are.
The two things will write at the end. So this is called what? Galvanizing. This one is also alloy. Nichrome wire, which is this red color thing, this is made up of nickel and chromium. They are also two metals. Nichrome, it is used to make toast. This is one more alloy. It is called stainless steel. This all things you might have seen if a building construction is there or a bridge construction is happening in your area. You might have seen this rod coming out from the pillars. This kind of thing. They are all very, very strong and they are made up of steel. Steel alloy. Steel means iron and carbon. And in that we add various things like chromium, nickel, and we get various different types of steels. This is one more alloy called fuse. A thin wire is there. This wire is called fuse wire. This fuse wire kind of melts when too much electricity goes through it and then it protects us. So such kind of fuse switches will have a fuse wire inside it like this. We will study more about this when we study a chapter called electricity. These are a few more uses of metals. Who can read nicely, very beautifully? Sarth, you can read. Chalo. Read quickly. Sarth, are you there?
Yes, sir, I am here.
Read.
Cooking vessels are made up of metals like steel and aluminium, as they are good conductors of heat. Electric wires are made up of mostly copper, sometimes of aluminium. Our bones contain calcium carbonate and calcium phosphate. Blood hemoglobin contains iron, Fe. Nickel is used to make coins. Tungsten is used to make filaments of electric bulbs. Titanium compounds are used in paints. Aluminium foil. Silver bromide can have light-sensitive reactions. It is used in photography.
Few uses of metal. This is one more use. What is the use? Coating the mithai, kaju katli. This is actually silver metal. This is how it is done. Kaju katli. So you have to take silver foil and put it on that like this. And then you cut the mithai into whatever required pieces. That is the way this mithai is made. When we eat kaju katli, that time we eat this silver metal also. It's a very small quantity. Our body cannot really absorb it. So if you eat like pura dabba bhar ke kaju katli, if you eat, that much silver metal will go in your body. But it will not get absorbed, it will come out. So if you want like it will be there in the output which you do next day to collect it and then extract it, it is possible to get silver out of it. Of course nobody will try like that, but possible. Now these metals are very useful. Wait a minute. Metals are very useful, but they get rusted, they get spoiled due to oxygen. Iron objects especially get rusted like this. This is called rusting. Copper do not rust, but it becomes greenish coat comes like it's called copper carbonate. Silver also not rust, but it will form black color layer. What that then small chip black color layer. Pitambari powder is it is called silver sulfide. So rusting is again a common problem, and we try to paint the iron objects and things to protect them. The last part about metals is there are some radioactive elements. These radioactive elements, they are called uranium, thorium, radium and plutonium. They are useful to us to make atomic energy in some cases, but very expensive and not very useful, at least for India. But second use is that they can be used to make atom bomb or atomic weapons. So uranium or plutonium, they can be used to do that. The radium was the first such substance discovered. It was obtained from ores. Ores means the mine. So you have to do mining, and that mine over the stones through which the radium is obtained called pitch blend. Pitch blend. It was done by Madame Curie. But at that time people were not knowing the radioactivity is so harmful, and then some deaths also happened because of these radioactive chemicals. And then later on we came to know that the rays are very harmful. Thorium metal is found in Kerala in India. Uranium is not found in India. It is found only in Australia and Canada mainly. Uranium is useful for atomic energy and atom bomb, but to very limited extent. That was a few things about metals. So many things you have studied about metals. Now very quickly, like few people have raised the hand. Very quickly we'll take that detailed question and answer session after the second part. Non-metals still we have to study. So जिन्होंने urgent कुछ हाथ ऊपर किया उनका खत्म करता हूँ 5 लोगों का काम. फिर जिनको एंड में तो you can ask I have a lot of time, so no need to worry about it. और still what जीतिका, what जीतिका, हरिका and अमेरा, क्या जल्दी ले पूछो very quickly.
So what is the algon?
No, there are two types of liquids. One is called acids and other is called alkalis. We will study about this when we study a chapter called acids and base, but long time too. Right now, as you elected. Non-metals are not malleable. You cannot hammer them. Coal is made up of carbon, for example. You cannot take a coal and hammer it and get a thin sheet of coal. So non-malleable. Make sense?
Yes, sir.
चलो और किसी का अर्जेंट नहीं है ना बाकी सारे क्वेश्चंस करते हैं we will do all the question after the finishing this second part which is non-metals part. So let us move to the non-metal thing. Now non-metals अभी कौन रीड अच्छा करता है तुम में से पहले तो इसने Joy will do. चलो Joy you are able to read ना Joy where are you? अरे not there only. You have to unmute.
Yes. Non-metals. Non-metals do not have luster, shiny appearance. Are bad conductors of heat and electricity.
They are not ductile, non-malleable, they have low melting point, easily they melt, they have low boiling point, means easily they boil, they are not sonorous, means they do not produce that beautiful sound, karke sound they don't produce like a bell. Hydrogen, nitrogen, oxygen, chlorine, bromine, iodine, carbon, phosphorus, sulfur are examples of non-metal. Now this non-metal, there are only 4 people in solid: carbon, iodine, sulfur and phosphorus. All of them we have seen in that video. That Udita was showing the sample of yellow powder, iodine which was like becoming fumes, and then carbon to diamond, coal, graphite, all are carbon. And phosphorus was there on the side of the matchboxes. Only one person is liquid. About non-metals you are talking about. Do not tell mercury. So that one is called bromine, and remaining all are gaseous form of element: oxygen, hydrogen, nitrogen. These are the 4 people who are solid, which you can see. Now, like there are very reactive metals, which when very reactive metals, lithium, sodium, potassium, like that, there are very reactive non-metals. And one symmetry is that if you see that periodic table, all very reactive metals sit in the first column: lithium, sodium, potassium, rubidium, cesium, bathtub wale people. All very reactive non-metals sit in the last row: fluorine, chlorine, bromine, iodine. These are all very reactive. Let us study them quickly. This is the video to show these 4 very reactive non-metals. Fluorine is the
Careful
most
how they have
reactive.
fluorine, bromine, hydrogen.
This is called fluorine. This is colorless gas. Yellowish green is called chlorine. And then this reddish brown liquid is bromine. And this solid is iodine. Bromine has got very beautiful color, like blood color, dark blood color. Now fluorine is most reactive. You put fluorine on anybody, it
The
reacts.
fluorine
You do not have to ignite
sets
it.
iron wool on the
Look at the
fire.
fluorine डालो, it reacts.
And it does the same thing to charcoal.
Charcoal पे डालो, charcoal का
Now
fluorine.
let's see the reaction with hydrogen.
Balloon पे डालो, तो balloon का
A
fluorine.
jet of fluorine gas pierces the balloon as it explodes with the hydrogen inside. Let's see it again in slow motion. Now you can see the fire.
Fluorine is very, very reactive.
Now the reaction.
And now the trouble is, if it is so reactive, it reacts with everybody. तुम्हारे ऊपर डालो तो तुम्हारा भी fluoride. Put it in the glass, glass का fluoride. So the trouble is, how do we store fluorine? To store the fluorine, you need some vessel. If you put the fluorine in, it reacts with the vessel and eats it out. What do? We store it into copper pot. When you ask what? How will it not react with copper? Answer is yes, it will react even with copper. And it reacts and forms a thing called copper fluoride. It is a compound. And what it does is like this. Suppose if you make a copper pot and put fluorine into it, or a copper pipe or tube or anything, suppose this is a tube which is carrying copper, fluorine gas, the tube will have some thickness. Now, out of that, all this inner copper will react with fluorine and a thick layer of copper fluoride will get formed over here. Thick layer will get formed over here, and that layer itself will protect the remaining copper. That is why we use the fluorine is useful. Even we put it in toothpaste, thoda sa. And when you brush the teeth, it reacts with the calcium in your tooth. And it forms a layer of calcium fluoride on your teeth. So your teeth will not get corroded or will not react, and then they will remain in good condition for a long time. So that element is called fluorine.
Between hydrogen and chlorine. I like the hydrogen.
Now chlorine gas is yellowish green gas like this, poisonous. If you breathe it, then our lungs die. This is hydrogen gas burning in this chlorine. Chlorine, usually oxygen supports burning. If the substance is burning, oxygen has to be supplied to it. But this chlorine gas also allows us to burn. Like hydrogen can
And lower it into a jar of chlorine. The hydrogen carries on burning, but with a pale blue flame. When the halogens react with hydrogen, the hydrogen halides are produced.
Even it is possible to burn a candle with this chlorine gas. Now candle burns with a yellowish bright flame in air or in oxygen, but in flow, this is small aluminum powder. And it reacts so nicely with fluorine. Here he is trying to show various aluminum with reaction of all, fluorine, chlorine, bromine, iodine. This is again to show you that they are very, very reactive. This liquid is called bromine, and a small piece of aluminum is put into it. The bromine reacts fast. Initially it is slow, but as the whole thing becomes hot and hot and hot, then it becomes very...
As the reaction gets going, it quickly takes on the appearance of a pit of hell. As with the chlorine reaction, there's white smoke. That's aluminium tribromide.
Very reactive. Same is
The reaction with iodine is just as spectacular. A little warming helps to get things moving, but once the reaction's off, it needs no further assistance.
That also is so vigorous.
The products of all four.
These are all four people which are very reactive. Chlorine, bromine, iodine. Oxygen is also very reactive. That's why oxygen is required to produce fire. What I was telling you is that even chlorine supports burning. So it is possible to burn a candle in the chlorine gas. It doesn't burn that brightly. It produces reddish color flame and it produces heat and light. These non-metals are inert. Helium, neon, argon, krypton, xenon. They are all inert gases. Inert means they will not react with anybody. The way gold we have seen, which is the gold is the best, that is inert metal, whereas these people are called inert non-metals. And the remaining are gaseous. These are also gaseous. And these are in very small quantity in the air. This argon is just 1% in the air, and the helium, neon, krypton are very, 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 very less. Most of the gaseous non-metals are in molecules by sharing the electrons. Like there is oxygen is there in the air, always two oxygens come together and they form a jodi called O2. Two nitrogens come together, they form a group called N2. But these people do not do so. They remain on their own because they are inert, they don't want anyone. This non-metals show property called allotropy. Means what? Same material can exist in different forms. For instance, this is coal and diamond and there is a graphite. These all are carbons. Everything is carbon, but the arrangement is totally different. This property is called allotropy. In the similar way, even sulfur shows allotropy. Sulfur is yellow color powder, that is the next non-metal. It is yellow color powder which we have seen, but it can also be converted into crystals. And this sulfur is poisonous. Small quantity of sulfur can be used in medicines. They are called sulfur drugs. Sulfur can burn in air to produce blue flame, and it makes a gas called sulfur dioxide, SO2 gas. This sulfur dioxide gives coughing sensation. It's called polluting. And then it gets dissolved in water and is responsible to thing called as acid rain. This sulfur is used in medicines and it is naturally there in onion, garlic, eggs, etc. This is the form of sulfur, crystals. Here also sulfur crystals are there. What Udita had shown you, that bottle was the powder. Here there are crystals. It is possible to make crystals. You take some powder and you heat it strongly. After some time that melts and then that liquid will get formed like this. This is liquid sulfur. And then you allow it to cool down like this. So you heat it.
Monoclinic sulfur is unstable above 95.3 degrees Celsius, and needle-shaped crystals of the element
the same way
from molten raw sulfur. The sulfur is melted.
अभी थोड़ा ठंडा हुआ है ना ऊपर, तो inside there is a liquid. So what you have to do is you have to pour the inside liquid sulfur out. अंदर का थोड़ा liquid निकाल, and then you get something like this. And if you cut it, you can see the needle-like crystals of sulfur like this. Chota sulfur crystals. So from powder, it is possible to get this crystal. This is one more example. Here he is trying to dissolve this sulfur into a chemical called cyclohexane, I guess, or there are some other things like carbon disulfide, and he is trying to heat it. Garam karke dissolve karo, and if you heat it, some more sulfur will get dissolved, thoda zyada, and that becomes solution like this here, yellowish color. Now you allow it to cool down, so that extra sulfur which was dissolved due to the heat will automatically get thrown out of the solution. And that also forms crystals like this. This is in fast forward, of course. It takes some 3 to 4 hours, but this kind of crystals will get formed. That is the second form of sulfur, powder and these crystals. So he has collected these crystals, trying to make them dry. See? Very beautiful shining yellow sulfur crystals. So these two are called allotropes. The powder and the crystals is called allotropes. Now the phosphorus. Phosphorus has two possible allotropes. One is called red and one is called yellow. Phosphorus was discovered by a German person from his urine. That time people were crazy finding a thing called as Philosopher's Stone. Have you heard of that? Harry Potter. Philosopher's Stone is a substance which was supposed to have magical property. Like you touch it to iron and it becomes gold, and you touch it to yourself and you become evergreen and young all the time. You'll never become old, and so blah blah blah. And all the people were like very much mad behind finding it out. And entire chemistry got developed into these people on them. They were not knowing anything. So what they used to do is try out each and everything. Everything they used to try. Whatever comes to their mind, they will try. So they will take soil, they will put milk, they will add some rice, they will put it in sunlight, they will put it in moonlight, they will add something like that they used to do. So this person, he collected a lot of urine, okay, in his big drum. So around 1,000 liters of urine he collected. And वो जाहिर है like भयंकर smell started coming, वो सारी सड़ गई, तो उसकी बीवी ने उससे घर से बाहर भगाया. That poor fellow shifted all his drum full of urine in the garage. And then one day he started heating it. So in a big vessel, he put all that and he started boiling it. And then after that boiling, he made a paste out of it. And in the next day when he got up, he saw that entire vessel was shining like ekdam mast hai. So he thought, okay, I have discovered the philosopher's stone. But later on he came to know that there is a new element he has discovered, and that element is called phosphorus. That phosphorus has the ability to glow slowly in air. Thoda. Why it glows is actually it keeps on burning. Slowly it will keep on burning, and so it produces flame, and therefore it kind of burns. And the phosphorus is also poisonous. And then we came to know that this phosphorus is a very useful thing. You can coat a wooden stick by that, and you can use it as a matchstick. Later on we found that instead of this yellow phosphorus which keeps on burning all the time, it is possible to get a different type of arrangement or allotrope called red phosphorus. The yellow phosphorus burns very even at room temperature, and therefore you have to store it underwater. On the other hand, the red phosphorus can be used to make matchboxes. The special surfaces which are made on the side of the box, they contain this red phosphorus. So you rub the stick on that will produce fire, and as phosphorus helps to burn, very quickly it will catch fire. That is the use of phosphorus. These are the possible forms of phosphorus. Yellow, and then all red phosphorus ke 3 types. These are again called allotropes. The last part is metalloids. Now, metalloids show some property of metals and some property of non-metals. Metalloids, there is no definition in chemistry as to when we should say one is metalloid or not. Generally, 5 people, silicon, germanium, arsenic, boron and antimony, they are called metalloids. Antimony is an element. Paisa nahi hai to antimony aisa nahi. And in the periodic table, if you see, periodic table kidhar hai apna, this one. These are all green color people who are sitting somewhere between these metals and these blue non-metals. They are these metalloids. Boron, silicon, germanium, arsenic and antimony. These are considered as metalloids. Okay. Out of them, silicon and germanium are very useful. Why are they very useful? Because they can form a thin wafer, and then we can make electronic compute components, computer chips out of them. So those chips are always there in mobile phones, calculators, this type of chips. These green color boards are called printed circuit board. They are always there even in keyboard, mouse, chota sa printed board. In computers, motherboard is a big printed circuit board. Always they are there. They are called semiconductors. So they are also metalloids. So that was the last part, metalloids. Now few things we have to, metals ka to we have written. What we have written? Abhi ek aadha question, chalo thoda few things we'll write quickly. One video I had shown you, in that a tin metal ka coat was given. This comes in the exam, 2 times it has come. A tin metal ka coat was given on copper pot. What was that called? Bola. Sir is only telling all the answer. Tum log kya kar rahe ho? Sir, tell. And then Omkar will tell next. That is called tinning. Then one more video I had shown. In that one nail was kept in a solution and it was not rusting. Compared to that, one more nail was there, it was rusting. Omkar, tell. What was that? Tell Ray Omkar quickly.
Galvanization.
Galvanizing. Likho ek line likho patak se. Tinning. What will you write? Very few things we'll write, but we'll write. Do not become very lazy. What I told you. Tinning. Fatapat likho. Tinning. What was tinning? Coat of tin on copper or brass vessels. And then one more coating was galvanizing. What was that? There was zinc coat on iron. Why do we do this? So that it doesn't rust. Then what we have seen? Then we have seen one thing called as bubble gum. What was that? Samya, tell.
Sir, it was amalgam.
Amalgam. What was that? Amaya, tell.
Amalgam.
What was that? Ayush, tell. Many people are telling now. Tell, Patak say.
Alloy.
What and what?
Alloy with mercury and
Mercury and what? Tell na.
gold, aluminium.
Gold, amalgam is Polo Regia.
Mercury, gold, or aluminium.
Mercury and gold is called amalgam. But mercury with other people is also called the same thing only, amalgams. Then, one video we have seen, in that there was a small thin रुको हाँ एक सेकंड ये क्या है बताना है तुमको This is also one alloy. ये देखो ये वीडियो ऐड जो ये पिक्चर वी हैव सीन व्हाट इज दिस बोलो now you are able to answer बोलो
electricity, short circuiting, fuse wire.
Then I have shown you one video in which there were 4 non-metals which were extremely reactive. 4 non-metals which are very reactive. ऐसा नाम metals का ये 4 we have seen. एक लाइन लिखो फटाफट ठीक है then there was one property that property was called allotropy. Allotropy का meaning is what? बोलो who want to tell this with example? Tanisha, tell quickly.
Yes, sir. Sir, for example, sulfur. It is in the crystal form also, and it is in the powder form also.
So allotropy means shortcut में लिखो. Same substance exists in different forms. Same substance exists in different forms. That is called allotropy. Example. एक example लिखो. What example you will write? Coal and diamond. That is a good example to remember. Coal and diamond. And then last part. Metalloids. Metalloid. Which metalloid? 2-3 metalloids we have studied. Do you remember any name? Samyak remember many things. Omkar also remember. Ayush. बोलो फटाफट.
Silicon.
बोलो फटाफट.
Arsenic, germanium.
तो तुम लोग सिलिकॉन एंड जर्मेनियम ये दो लिखो. ऑल ऑफ यू राइट दिस वेदांत पे. ऑल ऑफ यू राइट सिलिकॉन मेटालॉइड सिलिकॉन एंड जर्मेनियम यूज्ड इन कंप्यूटर पार्ट्स. पुश हो गया सारे. वेरी गुड टाइम. अच्छे से एकदम. All right. So many properties we have studied about metals, about non-metals, about metalloids. Many videos we have seen and actual samples also seen. Have you understood this?
it.